Let's talk about the ballistic pendulum lab. The idea behind this lab is that you're going to take a blowgun, okay, and very safely, you might want to clean off that with a little isopropyl alcohol, right? But very safely from some distance, probably, I don't know, 3 feet or so, you're going to fire, because you don't want the air from the pendulum, from the blowgun to hit the pendulum. But you're going to blow a dart, and the dart's going to fly across here, and it's going to stick in this thing, like that, right? And this thing is going to swing to some height. It's going to go, because it's going to be hanging on strings, right? It's actually going to swing to some height like this, right? Here. It's like, we need to draw a nice straight line. There we go. Okay. It's going to swing to some height like this, right? And from that height, you're going to need to measure that height. And I think what we're going to use is whiteboards. We'll put a little whiteboard marker on there and then have a little thing that makes a line like this, and it swings up. You need to measure that height. It'll make a mark like that as it swings up. Measure that height, and all you need is the mass of the dart, the mass of the pendulum, and this height, and you can figure out the velocity the dart had when it struck this pendulum, okay? So find the mass of the pendulum and the dart, measure how high it swings, right? Calculate the velocity right after the dart hit, and then I'll show you these calculations, right? All you turn in is a data table with the masses you measured, and then the 3 heights that it swung, and then show your 3 calculations of the dart's velocity. And that's it. There's no conclusion or any thing like that. Let me just show you this. Let's suppose that this was your data and you made a nice, here, we can make a nice data table out of this. Oh, look at that. Even use a straight edge. It's like, God, I'm good. How do I do that? That's crazy. You might even want to draw lines in here. Look at that, right? It's breathtakingly good, right? Okay, I don't know. I'm just holding the shift key now. Okay, so what we want to do here is let's draw a little picture of this, right? In the first picture, the dart's flying through the air like this. It's got a little cone on there like that so that it fits in there. So here it is flying through the air, right? And the block of wood is like, or the block, it's actually going to be a block of styrofoam, is hanging complacently like that, right? In the next picture, okay, the dart has stuck in this thing, right? And if this picture exists at all, right? So here's the dart sticking in there like that, right? Okay, and this thing has started to move this way because the dart is making it move. This is conservation of momentum, right? And then in the final picture, this dart will have made the thing swing up to some height that you're going to measure by some means that we're going to have to figure out. Okay, but it's going to swing up to some height, and we're going to measure this height, right? So the first thing to do is use this height to figure out how fast it was going there, right? Here you've got mgh. Here you've got 1 FMV squared, and for sure energy is conserved in that thing, right? So I'm going to go 1/2 mv squared equals mgh, right? Do you see that the mass is the same in both cases, even though I didn't draw it here, right? It's the mass of the pendulum and the dart. So can I cross off that mass? Oh, I think I can, right? So now we can just plug this in, right? 1/2 v squared equals 9.8. And then we've got to turn that into meters, right? So 0.063 meters, okay? And now I can do this. Let's see. V squared equals 2 times 9.8 times 0.063. And then, of course, to get rid of the squared, you're going to square root it, right? So it's going to be the square root of 2 times 9.8 times 0.063. Yeah? And that's 1.111, I'll say. I love that, meters per second, right? Okay, now I'm going to go back and I'm going to use momentum, because from here to here, kinetic energy is not conserved, but certainly momentum is, right? So here I know the momentum of this guy, right? This is going to be, what is it? It's this mass, right? So 0.18735. I'm turning it into kilograms, right? Plus 0.00913, right? That's what this mass is right here. So let's see, let's figure that out. 0.18735 plus 0.00913 is 0.19648. And that's kilograms, right? Okay. The mass here is, of course, our 0.00913 kilograms, right? Okay. So now we can just set up our momentum equation. 0.00913 times whatever this velocity is, and this is what we're trying to figure out. That equals 0.19648 kilograms, right? And then we know it was going this fast, right? Times 1.111 meters per second. Yeah? Ta-da. Okay, so now we're all set. We're going to go that guy times 1.111, right? Divided by 0.00913. And I get about 23.9. So if I solve for that thing, right? Now I have no idea what those dart velocities are going to be actually when we start doing them. Okay, I just sort of fudged this data so we'd get some number that wasn't like 5,000 meters per second. Okay, your data table is going to be the same, except you're going to have 3 changes in height here. Right, you're going to have change in height 1, so maybe it'll be like 6.8 and maybe 4.2 or something like that. All you have to do is just show your calculations for those 3 things. You're going to be working in groups of 2, and if you have to be a group of 3, then just do some more shots, right? Just do a couple more shots maybe, huh? I think we're good. This is how you calculate it. If you've got these notes, you should be just fine.